Joining me now is Dr. Nejat Altuntaş, Associate Professor at Tekirdağ State University, and we will discuss the COVID-19 vaccine, the coronavirus itself, and also the new strain of the COVID-19 virus. Good afternoon. Thank you for joining the program.
Thanks for having me.
Okay, now let's begin with just perhaps an overview of the coronavirus, and then perhaps we can talk about a little bit on the new strain that we have been told, and the reports indicate that it's 70% more transmissible than the original virus. So we'll just listen to that from you to begin with.
Yeah, okay. So let us begin how coronavirus comes and attaches to our body and how it enters our cell. You know, coronavirus contains at least 100 spike-like proteins on its surface. So on each spike, they have two subunits. One of them is this S1 subunit, the other one is this S2 subunit. These subunits, I know it's a technical term, but it's also important because to explain the mutations, we should learn these subunits. The virus uses the S1 subunits to attach the receptors on our surfaces, just like the surfaces on our mouth, in our nose. So the virus needs also ACE2 receptors. So with S1 subunit, virus comes to this ACE2 receptor and it latches onto this receptor. This is the first one. After latching or after attaching to ACE2 receptor, there should be a cleavage between the S1 and the S2 parts. And there is another protein in our body. This is our protein, not the virus protein. It comes and it cleaved or it broke this line between the S1 and S2. This time, the truncated S2, it's very easy for S2 protein to fusion the virus and our cell. So it enters our body very easily. So when the virus enters our body, it goes to our ribosomes and it produces its cells and it dominates our body. So why did I explain these subunits? You know, in England, there are 3 mutations. The first mutation is N501Y mutations. With these mutations, this mutation is happened in the S1 subunit. So it makes it very easy, or it accelerated the attach rate of the S1 subunit to the ACE2 receptors on our body. This is the first mutation. The second mutation, we said, you know, the S2 subunit is for the fusion. The second mutation is P681H mutation. This mutation is for the fusion. So virus can easily enter our cells. The other mutation is also very important. You know, when the virus enters our body, there are antibodies in our body. So it tries to catch this virus. With these mutations, the virus hides itself. So with all of these mutations, firstly, it is very easy to find our receptors in our body and to attach or latch to this receptor. This is the first one. The second one, the fusion of the virus is accelerated. The third one, hiding itself our antibodies or defense cells very easy. Now, that's why there is up to the 70% increased transmission or contagious rate of the virus now. That's why, but this is not new.
It's
it
not
happened.
New?
Yeah, it's not new because the paper just came out on 19 December. The paper. So if you'd like to write the paper, you should have some data, right?
Sure.
So this data started early September in England,
Yep.
especially south of England. So if there was cases in England, and if there was flights to England, I'm sure it's not just on Netherlands or Denmark. I'm sure it's everywhere. Maybe we are protecting our borders. We don't fly to England anymore, but I'm sure it's in everywhere. It can be also in Turkey.
Sure. See, that's right. See, because there were cases known in September. That's what we know now.
Yeah, yeah.
And it's been several months.
Yeah, maybe they hide this situation, because when you look at their the number of the cases is doubling. It's increasing exponentially.
Okay, so now we know that there's a vaccine. We know that there are various vaccines on the market, and this has been a very promising development. People have been feeling relieved that there's a vaccination, and now we find out about the new mutation. It's 70% more transmissible. And should the mutation reach a dangerous level, what does that mean for the vaccination? Will the vaccination have to be redeveloped? Will this current vaccination lose its effectiveness?
It's a perfect question. You know, especially mRNA vaccines, which was produced in Germany, the BioNTech and Pfizer companies' vaccines, and the Moderna vaccines, they are mRNA-based vaccines. They produce the spike-like proteins, just like on the virus. So our body, you know that this spike-like protein and antibodies and the defense cell comes and they destroy the virus. So this mutation happened on the spike-like protein. So there can be some problem on this vaccine, especially mRNA vaccines. But when we listen to the producer in Germany, they said,
Ur Şahin?
Yeah, Ur Şahin, yeah. He said there will not be any problem because there is only 91% it will not be effective, but other than 99, it will be effective. On the other side, you know, this is a very new technology, and they can change the code, and they can produce this vaccine very easily because this is not the conventional vaccine. But only problem with the storage. You know, they stored maybe 50 million vaccines on the shelves, so it will be vast. But on the other side, at the moment, we think that it's going to be usable, at least Ur Şahin is saying. But on the other side, especially with the Chinese vaccine, its technology is, you know, it's an old school technology. We know that this vaccine from 1895 is an old technology. So we are producing this virus, and then we are killing this virus with the alcohol formaldehyde and with the hidden, and we give this ineffective virus or inject this virus in your body. So the mutation will not affect the Chinese vaccine because we give the whole virus, not the only spike part, not the crown part. We give the whole part. So there will not be any big problem with the Chinese vaccine, I don't think. And on the other side, there are some good researchers also in Turkey. They think that this mutation will be beneficial for us because, you know, virus need the spike for attachment, for virility it needs, or contagiousness it needs. So if there is any change in the spike protein, maybe it cannot attach to our body. It will be a beneficial mutation this time, they say. Right. But at the moment, there is no any research paper who supported this idea.
Okay. So just in simple terms, I'm trying to make sure I've understood you correctly. There is optimism surrounding the effectiveness of the Chinese vaccine, right, but we're yet to find out if there's optimism surrounding the BioNTech Pfizer vaccine. Is that correct?
Yes.
Okay.
Yeah,
but Ur Şahin is the producer of the BioNTech Pfizer, and yet he's
no, there will not be any problem.
No problem there either.
Yeah, he says. But there can be a problem because you know they produce this spike protein.
Okay. What about your view? What's your analysis? What do you think?
This is my opinion. There will not be a big problem because there is only little change on the spike protein. There are at least 500 genes on the spike protein. Only 17 genes mutated. So it will not be a big deal.
Okay. So we've seen one mutation. There's a new strain, and we're all yet to discover exactly or understand the nature of this mutation. So far, we know that it's not necessarily dangerous. It appears that the COVID-19 itself was a lot more dangerous, even though this new strain is a lot more transmissible. In the coming days, is there a chance that we might come across another strain and more mutations, and could they potentially be more dangerous? Are we looking at darker days ahead? Because as a global population, we were hoping that by perhaps, June, we would be kind of free from the whole thing, and yet it doesn't look that way now.
But by the way, I don't say June, but in July.
July?
We will get rid of our mask.
At least,
yeah,
that's
at
good.
least, yeah. But it's also a good question. There will be, of course, mutations. I mean, beginning of the COVID-19 disease, there were at least 10,000 mutations on the virus. But there are very small mutations, and it's not a big deal. So if there's any mutations on the spike protein, the virus will not have a chance to attach our body. So on the other side, we are producing the vaccines, and in England they started, in the United States they started, and yesterday our government health ministry wanted the doctor's name for jab.
Oh, yes.
Yeah, so I don't know the exact date, maybe next week we will also start the vaccine. So this is the game changer vaccine. So on the one side, we have a now very powerful gun to shut the virus. This is the vaccine. On the other side, if there is any change, mutation on the virus, it will not have a chance to attach our body. So it's going to be also beneficial for our body.
Okay, so you don't see that there's a huge concern?
No, I don't think so at all.
All right, that's good news for sure. Okay, now I just want to move along into another aspect. We've all kind of learnt now the very basics: wash your hands, wear your mask, and now with the vaccine, obviously you should get vaccinated if you don't have antibodies. Should you still get vaccinated even if you have had the virus and you have strong antibodies, should you still get the vaccination?
Yeah, okay. Last month, I had a very serious COVID-19 disease.
Oh, you did?
Yes, I did. I was in intensive care unit.
Oh.
Yeah.
Geçmiş olsun, as we say in Turkish.
Yeah, thank you. I stayed 30 days.
Oh.
And after 30 days, I couldn't walk. And I had to use cortisone. I'm a very sportive person, but now I have some weight now. But when I check my blood IgG or antibody levels, I see that even I had a very serious, not the milder form, serious form disease, my antibody levels, there are two kinds of antibodies. One of them is IgM, the other one is the IgG. IgM shows that your disease is the acute disease. IgG shows that you passed this disease, you don't have any more this disease, and your body learned this disease, and you are protected to this virus.
Okay.
So when I measured my IgG level, even I had the very serious disease, my IgG level is low.
Is low?
Yes. So if you ask me, will I get this vaccine? Yes, I will get, because it doesn't produce enough antibody for the virus.
Right.
This is my sample.
Okay.
This is what I learned from my...
From your own experience.
Yeah, experience. So that's why even if you had the disease, if there's enough vaccine, you should get the jab.
You should. But what about if your IgG levels are very high?
Yeah, maybe you can wait.
To see.
Just 4 or 6 months, because we don't know the data after the 6 months. There are some data. It shows that the virus antibody protects your body. Up to the 6 months.
Up to 6 months.
So, but we don't know the knowledge or data what will happen after the 6 months. So you should get the injection maybe after the 6 months, before the people elder people, the people who have the comorbidities, they should get firstly. Then maybe you can get the vaccine.
Okay. Are there any serious side effects to the vaccine that people should know about?
No. As I said, especially Chinese vaccine is an old school vaccine. It's a conventional vaccine. We know a lot of things about this vaccine. Maybe there can be some aches, some pains on your muscle, headaches. Only problem with the mRNA vaccine we saw on the TV, but it's in 1 in a million you know, on the TV, there was a nurse. She got fainted after the injection. But this is very rare condition. No, there will not be a big problem in the short term, and especially after long term. In the long run, there will not be any big problem.
Okay. Now, I know your personal opinion. You're in favor of the Chinese vaccine, and you're saying that there's no issue in having the Chinese vaccine done. But especially in Turkey, and you would know this a lot better than I do, a lot of people are very skeptical about the Chinese vaccine. There's a lot of speculation surrounding it, and for some reason there's a lot more trust in the European.
Yes.
Why is that? What do people know that actually leads them to believe that you shouldn't trust the Chinese vaccine as much as the European vaccine?
Because it's coming from Chinese. Every Chinese product is cheap. It can break very easily. 1 Turkish lira. There are some stores, they sell their products for 1 Turkish lira. That's why they think, oh, Chinese doesn't have the cutting edge technology. On the other side, the Sinovac company is a very developed company. The first time they produced the hepatitis A vaccine. This is their breakthrough. So we get the hepatitis A injection from their company. There's no big problem. When it comes to this vaccine, everybody have skepticism because they think that we didn't have a chance to buy the European vaccines because they were expensive. But it's not true. Chinese vaccine is as expensive as the other vaccines. And also it is much more difficult to produce this type of vaccine than mRNA vaccines.
Okay, all right. So it's just being judgmental, as you said, about Chinese products are inferior.
Yeah, prejudice.
Prejudice, yeah.
Bias.
And so that means the vaccine must be inferior.
Yes.
Okay. All right. Thank you very much for joining the program. There's so much more that I could potentially talk about, but we're running out of time. I hope to have you on the program again and discuss this issue and many others in more detail.
Thank you. I really appreciate it.
Thank you. Thanks for joining us.